I want to welcome everybody to today's webinar series called Generative Entrepreneur. Today's talk is really going to be talking about open source models versus proprietary foundation models. We really want to help you understand in the great universe of models available to us, which ones would be best for your application, and really drill into in more detail the Phi-3 models. My name is Jason Virtue, and I'm a Principal Partner Solution Architect at Microsoft. I work within the GPS Americas organization with our ISVs and SIs, helping them build generative AI applications and helping them with their readiness needs. Today's talk is really going to do a discussion around our open source versus our private foundation models. We want to help dispel the myth that one size fits all is the best model you should use. This is a myth which we want to give you some context around. Once we give you that context, we want to help you understand which model or what models are available to you and how you go best about selecting and evaluating those models. When you get that idea, then we'll jump into the Phi-3 family and help you understand how those models are available to you and why those might be better alternatives to some of our GPT models that sit out there. We'll talk about different ways of deploying those and give you some sample code within the Phi-3 Playground. So let's jump in and give you some background. This idea of one size fits all is definitely a myth that sits out there. What we really want you to understand is when you start to work with these models, it is very important to understand what is your business use case. And what I typically see is a group of developers when I work with them on a daily basis will typically sit down and start to talk about how we can build out their generative AI application. And during those discussions, I usually get a very common response that, hey, I want to use the best model that sits out there. I've gone to the leaderboard, and through that leaderboard, I've determined that the best model available to me is the GPT-4 models. Now, typically they've done some research. They might have gone to, some benchmark studies that they got, similar to the one you see here on the screen, but they're typically looking at that average that sits there, that line that you see there, and they'll go to the far right of the graph and pick those models that have the highest averages. Now, hopefully we're starting to get the sense that there's a lot more data points on that grid than just that average line. And those data points are really showing you what those models are good at for different types of tasks. And that's really the piece that we need to focus on. When I sit down with our different partners, one of the core things I'll ask them is, hey, you told me that GPT-4 model is the best, but why is it the best for you? And that tailorization of the model to your use case is critical to your success. And hopefully that reflection helps them start to understand why they picked the model and then justify that in our discussion so that we feel comfortable with our evaluation of those models. Now, when we start thinking about the models, we have a multitude of different models that sit out there. And there's really two different spectrums that we typically look at. The size of the model in terms of are they large language versus small, and also whether these models are proprietary or what I call private, or are they open source. And there's going to be benefits and drawbacks of each. I'm just going to focus on what are the benefits of small language models and open source models so we can start to relate to things that might be net new to us and to the Phi-3 family. When we talk about the benefits of these small language models, the core benefit that I really see out here are twofold. One is accessibility to older hardware architectures. This is really important. When we think about small language models, we can start to run these not just on GPUs, but potentially on CPUs. Or if they do require a GPU, they might not need the latest NVIDIA A100 or H100 chips. They might be able to run on just a simple gaming chip that sits out there. That's going to be a really big benefit of a small language model. Low latency and performance of those models, cost and affordability, and enhanced security are going to be other good benefits. The security is going to be really pertinent because now these models are going to be good at very specific use cases, and we can start to build our system messages to ensure that they only address those specific use cases and instruct the model to only answer those categories. But lastly, and probably one of the biggest areas that we start to see these models really excelling on is obviously older hardware architecture, but also on-premise or edge deployments. Small language models now can go on phones, on PC, on edge devices, server architecture within your data center, and that multitude of deployment options is a huge benefit and where we see a lot of our organizations going and why you need to think about this as you start to build your generative AI applications. A next one is going to be what's the benefit of open source models? Why am I going to be using some type of open source software or open source model? In this case, one of the things that we can really be confident about is those open source models are going to be very transparent and verifiable. They will not be black boxes. They also can be very flexible and we can customize them and fine tune them as needed. We can look at those models, and in majority of cases, they're going to be more cost effective than their proprietary models, and they're going to be easier to integrate within your overall production suite. The key variable here is that those models, because there is a large number of models, can start to address a more diverse set of tasks or use cases that sit out there. And that's really one of the big reasons for open source. We want to customize these models, fine tune them, understand their capabilities, and more importantly, because we have a rich set of models that sit out in that community, we can now start to use potentially an ensemble set of models to then make sure that our application can start to address a very diverse set of use cases. So hopefully that's starting to make sense to you. What I want to give you is a little research paper out there. I would go to Eureka ML Insights, and there's a paper that Microsoft published. If you type in on Bing search engine, Eureka ML Insights, there's a great set of content that sits out there that talks about how we can evaluate these models. As I spoke of earlier, looking at the average benchmark on the leaderboard probably is not going to be the way of evaluating those models and getting the best model for your use case. Many other variables. And what they highlight here is first and foremost, we might have a use case that's looking at multimodal capabilities versus language. And with that, there might be different types of tasks or capabilities that we're looking from those models. In the outer rim of both of those web graphs, we can see those capabilities. And as we look at the color of each one of those web graphs, green, red, and blue, we can see the best performance of those models versus the max achievable and the lowest. And as we start looking at, say, the multimodal, we can see all models are very bad. Well, let's rephrase that, are not ideal for geometric reasoning. So Claude, Sonnet, and Gemini Pro are the best in that category, but Lava models are not. But where they really excel is counting in a grid. So GPT-4 does a really great job there. It does a little less good at navigation, but in spatial analysis, it does really well. But in visual prompting, it is not even on the chart. So looking at these different capabilities are going to be very important for you. And they have a set of test scripts that they've provided that can help you start to look at those models and see where their strengths and weaknesses are, standardize them, and help you understand. I think they have a standard 15, which ones might be the most relevant for you. I would not use this as my workbench engine, but it can be a good set of research papers to study to understand the capabilities models and improve your understanding of this environment. So let's now go into the benchmarking discussion. When we talk about the universal models that sit out there, there's over probably 1,500 different models that sit out there in many different model catalogs. Within the Azure platform, we can see in our Azure AI Studio model catalog models from many different providers. be it through Hugging Faces or NVIDIA or Snowflake or Cohere, to also different types of models, both large language models that sit out there and small language models. So it's a rich set of capabilities that you have out there, but it's also probably a little bit overwhelming to know which model might be best for you. So let's take a minute or two to help you understand how do we evaluate and select these models. Now, with that catalog, we also have to think through the hosting environment. There's different foundation model hubs that sit out there. Azure AI Model Catalog is just one of them, but you might also be looking at things such as Onyx or Olama, Hugging Face, or ML Studio. If I want to use this in a container, Olama might be a great component. If I want to use this as a cloud-based endpoint, I can use Azure AI Model Catalog, NVIDIA, or Hugging Faces. Or if I want to bring this into my data center, OpenVINO or Onyx Runtime can be great options. Or if I want to bring this to my local PC, things such as the GitHub Model Catalog or AI Toolkit and VS Code can be other methods to bring these to different endpoints. Now, in the end, we were talking about picking the best models. And from a taxonomy perspective, when you're in the catalog, these will be all the different areas that you can start to evaluate those models on. And you can pick and choose which one is best for you. Now, let's get into that evaluation piece. As I said, we have a plethora of models. Which one are the best for us? And let's talk about that workflow. As I said at the very beginning, understanding the use case is your very first step. Identify that use case, understand your success metrics, and define what tasks will address that use case. With that, then you should go into the benchmarks. You either can go into the leaderboards that sit out there, and that's one option that's available to you, or you can go into Azure AI Studio Catalog and leverage that, but pick your top X number of models that you want to do testing on. Once you do pick those top models, then use your data and prompt flow to start to evaluate those models so you can see which one is the most performant. Now, that's your benchmark. We can always do better than that benchmark because we can enrich that data with a RAG-based architecture or potentially fine-tuning to help improve the actual accuracy or groundedness of those models as we see fit. And then lastly, we always want to do responsible and secure AI. And so we'll start to red team those particular applications and also start to determine if we have harmful or say prompt injection or jailbreak attacks on those applications to see if our models can handle those effectively. Now, one of those benchmark tests can be from a Helm. Helm Light is published by Stanford, and the Center for Research on Foundation Models, that's part of Stanford, has developed that benchmark study. Has a number of different metrics out there, and you can pick the best metric for the job that works for you. Now, these are the metrics that you can look at, and this is very important from a benchmarking perspective. If you are trying to do some type of text generation use case, truthful Q&A and MMLU will be very important. We want to make sure it's truthful and the language is readable. But let's say we want to build a set of co-pilots or agents where we're trying to outline a given set of steps to perform. Now, the next two, HelloSwag or Big Bench Hard, would be things that we want to look at from a reasoning perspective. But maybe our use case is completely different and we just want to generate code. So human eval or codex glue would be other benchmarks we can leverage. And then if we have more of a conversational AI use case, the last two can be there. So look at the benchmarks that's relevant to your use case. You might have to look at them all or a very specific subset. But this will hopefully help you understand what are those top performers. What's important is once you pick those, say, top 3 or top 5, is to read that model card. If it's an open source model, it'll be very explicit on the things it can and cannot do. It is very specific also for proprietary models, but this will start to tell you, in this case, what are the tasks it can do? It can do text generation and it also can do text classification. But the Llama 2 model is a model for English. Now, as you read the intended use and what it's out of scope for, it definitely says it is tuned for research use in English. It is not used for other languages. So these tuned models are intended for assistant-like chat, whereas pre-trained models can be adapted for a variety of natural language generation tasks. Very explicit on what its benefit is for Llama 2. Thus, this would not be the model you want to leverage for, say, Spanish. Maybe a Cohere model would be a better alternative. Now, once we pick the top three models or top five, we then need to start running tests against these, automating our test scripts and looking at our evaluation metrics to understand how these models are performing. And based on our user application and the success metrics, we can see which ones are the most important for our given user community. These metrics, be it groundedness, relevance, coherence, fluency, or F1 score, these are the definitions for those, will be what you will use to pick your top model that sits out there. Now, once you get that top model, as I said, you still need to, say, test out different prompting techniques or a different RAG-based architecture to ensure we can even improve it more. So these will just be a start. Now, to summarize the workflow, typically what I see most organizations doing is jumping into the playground to do a manual evaluation to understand the capability of their quote top 3 or 4 models that they've used from their benchmarking study. So this presumes that they've done the benchmarks already. Once they test it out, just kind of understand the strengths and weaknesses of those models based on the model card. They then take their data set and their prompt flow scripts that they have and run those to evaluate those models based on the evaluation metrics I spoke of. In the tracker and the evaluation UI, they'll be able to quickly see which one's the winner, and they'll go through a multitude of different scenarios, be it through their prompt techniques or through their um, new RAG-based data sets or sources that they bring in to then optimize that model. And once they feel they have it in its optimal state, they deploy it to production. And just like with any normal machine learning model, we always need to monitor it. We can have drift in those models, or we can start to see potential attacks on those models, and monitoring those will be a very important part of that workflow. So now let's transition into the Phi-3 family. And we've talked a lot about the full universe of open source versus private models that sit out there and small versus large. The Phi-3 family is really a set of open source, small and medium size language models that sit out there. What's great about this family of models are they are not just text-based models, but they are also vision. So they're multimodal type of models that sit out there. And what's been nice about the Phi-3 set of models are these are open source models. So they are not just models that are available only within the Azure AI Studio cloud. They're available through many other hubs that sit out there, through Olama or through Hugging Face. These models are now going into the discussion we had at the very beginning of the benefits of both open source and also of small language models. These models now can be deployed on a multitude of different devices and architectures. And the Phi-3 mini models can easily be done on mobile devices. Our small models can be done on PC-like devices, and our Phi-3 medium models, which have around 14 billion parameters, now can start to be done on more PC or server-based architectures. What's great about the Phi-3 models, which were released in April, we have the ability to do both text and vision, and the Phi-3 vision is multimodal. Now, just in the past month, we have a new release of the Phi-3 family, and that's the Phi 3.5 family. And what is the major net new enhancements to those models is the ability not just to do them in English, but in a multitude of different languages that sit out there. There's a very prescribed set of languages. I'll let you read the documentation to get those, but they are multilingual models. We've done the mini, we've done the vision, and we have a new one out there called the mix of experts, Phi 3.5 MOE. When we talk about the mini, as I said, 3.5 versus 3, language is a big piece, and the context windows now is at 128. Vision, we have the same thing as the 3, but the next net new capabilities improving of things such as object detection and recognition, but also providing a series of images together and describing the differences across those images. So if you have a time series or a multitude of different images, it can start to tell you the differences across those images. And lastly, the model mix of experts. This is a very interesting piece. Um, there's 12 different models that are part of the Phi 3.5 model family. Each one of those models has approximately 6 billion parameters. And what I'll do is I'll take that input, put it through all the models, and determine which model has the best results for you. So that mix of experts now can start to do much more complex reasoning tasks that sit out there and start to simulate the performance of a large language model. So that mix of experts really starts to allow us to get at a much more grounded and performant set of models. Now, let's jump into the deployment options. As you can see from the Phi-3 models, the different runtime environments that sit out there. As I said it earlier, the key benefit of a small language model are its deployment options. And from this chart, you can see that we can support many different runtime environments across many different foundation model hubs. Now, let me finish the discussion around the Phi-3 vision model. And I like to have us use a hypothetical use case where we're building an insurance claim application. I'll show you a demo at the end of this talk on this so you can see a real world example. We want our customers to take a snapshot of the pictures of their cars in real time after their accidents have happened. We want to use this claim so that a human can be in the loop and start to stream their claim video of their car so that we can start to provide the right reimbursements that they have based on the damages that happened to their car. The family of Phi-3 models that we're planning to leverage can be brought onto that mobile device. When they're on that mobile device, we can use its multimodal capabilities. We can either use Phi-3 or Phi 3.5 vision. If we want to look at the changes in a time series, maybe the before and after, we can see those changes in that model. And we can start to look for its capabilities. And in this application, we want to ensure we can do dense captioning, text summarization, reason object detection, and recognition. And we want to do this in a multimodal capability so we can use both text and images. This is what we will be doing when building out this insurance claim application. As I said before, I'll show you a hypothetical example in a video here shortly, but hopefully this will start to give you an idea of the use cases that support Phi-3 vision models. So let's jump into the last component here and talk over the deployment options. In this example, if we wanted to start to test out that on my local computer, I can use VS Code and an extension called the AI Toolkit for VS Code, and I can then start to experiment with those models on my local PC for, let's just say, unit testing to understand if these models are going to meet my given use case. But if I want to start to bring them into other environments, I can bring them into Onyx, and there's a link here, and I'll share these also in the show notes for Onyx. I can do this through Olama with containers, and I can see what type of hardware it'll support if I bring it to my local PC with VS Code. So, hopefully that starts to help you understand what is our options and instructions on how to set these up in your environments. Where I will conclude is in our Phi-3 playground. When it comes to Phi-3 and the playground that sits out there, this will be a great learning resource for you to leverage when building out your application and using these Phi-3 models. This cookbook is part of a GitHub repo that'll have sample code and learning resources available to you so you can start to understand these concepts in a much deeper ability than maybe what I've provided. And you can start getting some hands-on um, experience through sample code when using when using the GitHub code spaces. So I encourage you after this talk to open up the playground and start to experiment with it. Now, where I like to conclude and send us to the very end is on a video that will demonstrate an insurance claim application using the 5.3 vision models and comparing it against the GPT-4 models. I'll let you watch this and see how that goes. What I like to do is thank you for listening to today's talk, and definitely please share your feedback with us and look forward to talking to you in the future.